Hurry, can you explain everything about baryons on AP Calculus? Well, unfortunately, I didn't take AP Calculus, so I can't be able to explain everything on it, but I'll try to do my best. This one says a fire is spotted from two lookout stations that are 10 miles apart. The bearing from the first lookout station to the fire is north 52 degrees east. The bearing from the second lookout station from the fire is north 37 degrees west. Find the distance from each lookout station. Okay, so the one thing I always told my students when we're doing bearing problems is create your cardinal directions. So create a northeast, southwest. At every single time there is a point or a fire. Let's just undo these because that's horribly bad. So let's do one like that. We're going to do it like that. We're going to do it like that. And then we're going to do one right here. Okay, so I just do that for every single one. And that helps because now, if we look over from here to here, we can send that those are going to be 10 miles apart. And then we have this as a direction, and that is going to be north. So you always start at north, 32 degrees east. So that's going to be 32 degrees. And then from here to there is going to be north, 37 degrees west. Okay, so we have a triangle. We obviously need to find missing parts because it says find the distance from each lookout station to the fire. So let's call this little a, so that would be big A. Let's call this little b, so that would be big B. And then this could be big C. All right. Now, if this is 32 degrees, we know that this now has to be 58 degrees. Sorry, that's 52 degrees. How did I do that wrong? That is 52 degrees, so that's going to be a 38 degrees. All right, so we have 52. So therefore, that's going to be a 38 degrees, right? And then if that's 37 degrees, we know that this has to be a 53 degrees, right? Because these two angles have to make up a 90-degree angle. That's what's nice about having your cardinal directions. So now you can see that I have a angle, side angle, which again, I can also find this third side, which is going to be, let's see, 180 minus 38 minus 53. So that's going to be 80. What is going to be 92, which is going to be what, 108? No, I don't want to make sure I'm making my math. Let's just do it. So that doesn't, no, that's 101. I'm just going to stop talking. 38 minus 53, 89. Wow. 80, 89, 90. Yes, that'd be 91. That adds up to 91. Yeah. Okay. So that's going to be an 89. Cool. All right. So again, we got that from 180 minus 38 minus 53. And that's how we got to be big angle C, which ends up being 89 degrees. Showing my work, which I got there. Okay, so now the nice thing is I have two missing side lengths, but I have the opposing angles. And I also have a ratio or a comparison between an angle and a side length. So therefore, I know I can use the law of sines. And I don't have to be worried about the ambiguous case because I already have my angles already defined here, and they all are acute, which is going to be nice. So we already have everything defined, so we're good there. So therefore, to use the law of sines, all I'm simply going to do is I'm always going to keep with this ratio here, and then I'm just going to create the ratio to find B as well as to find A. So to do that, I will say I always put the side length on top because you always want to solve for the variable on top. So it'd be A over a sine of 38 degrees is equal to a 10 over a sine of 89 degrees. That's going to be for A. And then for B, it's going to be B over the sine of 53 degrees is going to be equal to, again, 10 over the sine of 89 degrees. And now to go ahead and solve for A is going to equal a 10. I'll write that up in front, times the sine of 38 degrees all over the sine of 89 degrees. And then over here, I'll have B equals a 10 sine of 53 degrees all over the sine of 89 degrees. And now we just need to plug and chug. So do 10 times sine of 38 divided by the sine of 89. And in this case, I'm going to get A is equal. I'm just going to truncate it. 6.15. And then over here, I'll do a 10 times the sine of 53 divided by the sine of 89. And in this case, I get B equals a 7.98. Again, I'm just going to truncate everything. And do those like make sense, right? If you have a 10 here, does it make sense that A would be 6.15 and 7.98 for B? Yeah, it does. Like it works, right? So that it makes sense, in that regard. Sometimes students will get like 61 or 798. And it's like, whoa. That doesn't really make sense in there on the triangle. So that's always good to kind of verify that and double check in that regard.